while on a 6.5-hour spacewalk. On the International Space Station in 2017, astronauts Peggy Whitson and Shane Kimbrough experienced a bit of clumsiness that would pose no problems on Earth but can cause some major headaches in space. They dropped a piece of debris shield that was part of the docking ports of fabric covering that weighed 8 kilograms and measured 162 centimeters by 59 centimeters, about the size of a corridor, and that debris shield had an important role to play. It was supposed to cover a docking port on the ship, protecting it from extreme temperature changes and orbital debris, something the ISS could not do without. The shield was a Whipple shield that uses the hypervelocity of space debris to its advantage, using thin layers of shield to obliterate the debris into tiny fragments that the inner shield can withstand as the energy of the debris is spread out over a larger distance. Back on Earth, the mission control team got to work thanks to the fact that they had replicas of everything in space, every night and bolt and every piece of fabric. Mission control found a way for Whitson and Kimbrough to use wire ties and a different piece of cloth as a substitute for the lost Whipple shield until a replacement could be sent up on another rocket. Having dealt with the problem, there was one more thing to worry about: whether that lost piece of shield would come slamming back into the space station. The shield was monitored closely for 2 orbits before it was determined that there was no risk it would hit the ISS. Kimbrough and Whitson could breathe the sigh of relief, and Whitson could properly celebrate having completed the most spacewalks of any woman. But just how common is it for astronauts to lose grip on tools and other objects while in the microgravity of space? How costly are these brief bouts of butterfingers on the ISS? And what happens if the newly made space debris is on a collision course with the station or another light? These are all scenarios NASA and the astronauts themselves have to prepare for. Like anything else, sometimes accidents happen. The lost shield wasn't the first time astronauts have lost something in the swirl of space while conducting an extra vehicular activity or spacewalk. In 2006, astronaut Piers Heller dropped a spatula while doing work on the space station, and apparently had a lot of spatulas waiting for him in his office when he came back to Earth after the mission. That same year, another astronaut lost a camera, and in 2008, another astronaut was applause. We have a lost foreign. Part of the reasons items can become lost is because of the challenge of maneuvering small objects while wearing massive gloves. Astronaut Drew Feustel has gone to space 3 times for a total of 226 days and conducted 9 spacewalks, accumulating the second longest amount of EVA time among U.S. astronauts. He's pretty familiar with the difficulty of doing work in a bulky 160-kilogram spacesuit. I equate it to wearing a set of mechanics gloves with welding gloves on top. You know, that's how it feels, getting tactile feedback through your fingertips and through your hands. It's not really a good way to train that, except to expose yourself to that environment. And the way NASA has astronauts practice in advance of going to space is by wearing their suits in a massive pool, which has a precise recreation of the ISS built underwater for the astronauts to practice on. They learn how to maneuver in their suits, how to manipulate tools for repair work, how to move objects from one area to another, and how to perform an emergency rescue on team members, all while still on the planet. It's a pretty good analog, but not everyone gets as much time to practice as they might like. Historically, during the shuttle era, space shuttle era, when we're flying to space, we would train about a 10-to-1 ratio, meaning we'd practice a technique or a task at 10 times underwater for every single time we saw in space. So for every hour of work in space, we'd have about 10 hours under in the pool underwater, training those tasks, and that allows you to really build that knowledge of what you can expect the feedback to be through your hands as you're working with the objects in space. We see much less of that now. We're probably closer to a 2 to 3 to 1 ratio, if that, so it's more difficult to have that exposure, and it becomes a challenge. The astronauts have a number of safeguards for themselves and all their hardware. Once they're outside the station doing an EVA, they're always attached to Small tethers on retractable reels that are either 17 meters or 26 meters long, which will self-retract, allowing the astronauts to move around without fear of drifting too far. On top of that, they have small local tethers that only extend about 1.5 meters, but they still have a little more room to maneuver than there are all the other tethers for the tools bags and whatever other gear they might be carrying. We always attempt to make sure that every single item that goes outside of the airlock with us has some attachment to something, and that's achieved through those tethers. We are not always successful in keeping those tethers attached, and it's always a little bit scary when you find yourself holding an object and you realize that there's no tether attached to it either, because it was bumped off or it came off accidentally, or in some cases it was never attached in the first place. I've had a couple of experiences with holding items that didn't have tethers on that I expected to have tethers on, and those are the times when you very carefully reached out and find a tether somewhere, anywhere to connect back to that thing. Thus, on one particular occasion, during his 9th spacewalk in March 2018, Foist lost hold of an object he'd been working to install cameras and wireless communication equipment next to a docking port, as well as curing a loose component on a solar array blanket box. When he lost a wire tie, what he describes as something like a big garbage tie, when he pulled the tether to which the wire was attached, it turned out the jaws of it were still open, and the tide quickly floated away. There have been crew members in the past who have lunged after objects. You could maybe do that if you have a short tether on, you're not going to lunge very far. If you have a long tether on and you lunge, you're going to travel for another 55 or 85 feet before that tether hopefully stops you from your motion, and you may or may not have been successful at reaching the object that is now floating away from you. But in my case, I was attached to a foot restraint, which means my feet were fixed. There was really no way, and I simply watched this object, once I realized it was gone, just float away from me. And at that time, all you can really do is call mission control and say, I've lost an object, and this is what it was, and this is how large it is, and this is the direction it's traveling, and this is how fast I think it's going. And then that data gets reported to our tracking officers at mission control, and then that gets reported pretty much around the entire space debris network, which exists not only the us but internationally too. Track items that are floating in space that are not really controlled in any way, just as with the piece of drop shield in 2017. NASA had to closely monitor the trajectory of the little wire tie, and in this case, despite the object being much smaller, it ended up being more of a problem. What I was told after the loss of my wire tie is that for the first time in history, a satellite had to change its orbital altitude because of a free-floating object in space for fear of damage to satellite, and that object was my wire tie that I had lost, was floating around and had an impending collision with some type of satellite, and they actually had to change the orbital altitude of that satellite in order to create a greater distance or miss distance between those two objects. And something as small as a wire tie could destroy an entire module on the space station, or even and cause catastrophic damage to any piece of equipment in space. Of course, this issue with debris goes far beyond a few mishaps with astronauts losing hold of things while on Eva. NASA has a pretty good track record on the vast majority of spacewalks. Everything that's carried out is carried back inside. The real problem is that debris has been accumulating in orbit around Earth ever since the space race began with the launch of Sputnik in 1957. By 1979, debris from satellites and failed rockets were already posing enough of a problem that NASA created the orbital to pre-program to monitor the accumulating number of small objects that could cause damage to spacecraft. This program uses a network of ground-based and space-based observation techniques like the U.S. Air Force Space Surveillance Network, which can keep track of larger objects in space, while ground-based radar like the Goldstone solar system radar can detect. Much smaller objects, of course, it would be impossible to keep track of all the debris. Today, there are 23,000 objects larger than a softball orbiting Earth, 500,000 1 centimeter size, fragments, and over 100 million microfragments that are 1 millimeter or slightly larger, so computer models have been developed to log and track space debris, which alerts controllers when a collision becomes a threat and allows avoidance maneuvers to be performed. The ISS has a risk management system when a potential collision is detected. The ISS has an imaginary box drawn around it 50 kilometers squared and 0.75 kilometers